So with this problem, we are being asked to find all the zeros. And in order to determine where I have a real zero, I looked at a graph of polynomial function and found that there was a zero at x equals -1. Now, it's important to think about what this means. That means we had a factor that was x plus 1 times x plus 1 to get a zero of -1. Now you might be asking, why did I repeat that? That's because since this touches the x-axis instead of crossing it, that means that we had a multiplicity that was even. So we had a factor that was squared or had some even exponent there. So what this tells us is that our -1, our zero of -1 is duplicated. So we will use that twice in our synthetic division. And let's go to our synthetic division. So we'll use the zero of -1, our coefficients from our original polynomial function, and always bring down the first one. Kind of leave lots of room here. I'm going to try to write a little smaller. -1 times 1 gives me -1. So -3. -1 times -3 gives me a +3. That adds to 4. -1 times +4 gives me -4, which adds to 8. And -1 times 8 gives me -8, and that's a 0. And we knew that. So let's look at the depressed polynomial at this point. That is x to the third minus 3x squared, plus 4x plus 8. But since there's no way to factor this, which would have to be factoring by grouping, and there's no common factor there, we have to do synthetic division again to depress it even further. And if we didn't know that -1 was a duplicated zero, we would have to go through the list of potential rational zeros to see what else would divide into this. But we know that -1 is represented twice. So I'm going to repeat my synthetic division, but now I'm using this polynomial. 1, -3, 4, and 8 are my coefficients. Let's see if I can get a little straighter line this time. Bring down my 1. -1 times 1 is -1. That adds to -4. -1 times -4 is a +4. 4 plus 4 is 8. -1 times 8 is a -8. And again, we see that -1 is a 0. Now let's rewrite our depressed polynomial. So now it goes down 1 degree on each term. So now it's x squared, 1x squared, minus 4x plus 8. So there's my new polynomial, and it is a quadratic polynomial. Now I need to find the x-intercepts. I need to find zeros. We won't say x-intercepts because we know that we have found the x-intercept. The other zeros are complex, so these will not be x-intercepts. But I'm still going to use the quadratic formula. I can find complex zeros using the quadratic formula. So a equals 1, b is -4, c is +8. And we have that x equals -4 plus or minus square root of -4 squared minus the product 4 times a times c, and that is all over 2 times a. When we simplify this, we have that x equals 4 plus or minus, and we've calculated our discriminant and found that to be -16 all over 2. And using what we know about complex numbers, this rewrites to 4 plus or minus 4i over 2. Now remember that this 2 is the denominator of both the 4 and the 4i. So this simplifies to 2 plus or minus 2i. So remember that when we originally talked about polynomial equations finding zeros, that there is a total of 4 zeros. The complex ones are always in pairs. We know that there are 2 complex ones, and since there had to be 4, we had 1 real that was a -1. We have 2 that are complex. So again, this shows you that that -1 had to be duplicated so that we had our 4 zeros. So our zeros are -1. I don't need to write it in the list twice, though I would need to put it in a list of factors. 2 plus 2i and 2 minus 2i.